Hi, everybody. Welcome to this Ask the Expert series. The first series we're gonna talk about. We have the expert to talk about high availability, how to minimize the downtime and increase productivity with high availability. So let's get started. So my name is Kevin Lee. I work in the EDB, leading the sales engineer team, and in the team there are lots of database experts, and one of them is Borys. So welcome, Borys, to this Ask the Expert session.
Yeah, thank you, Kevin. Yeah, my name is Borys Neselovskyi, and I'm working at EDB as technical sales engineer. And yeah, I'm working with Postgres the last 1.5 years. And in my previous job, I worked with Oracle technology, and high availability was always my favorite topic. Yeah, and I'm really looking forward to discuss high availability with you.
Great to have you here, Borys. I appreciate it very much. Let's get some structure going. So it's going to be a very interactive session, this one. We're going to use less slide, more about talking through some of those topics about high availability. And in fact, Borys prepared some great demos to showcase what does high availability mean and how does that work. So first of all, we're going to talk about some concepts about high availability, just to set the base. What is the foundation of that? Some clarity about what is high availability. And then, and Borys and I would discuss about the RPO, RTO, and GRO, all these acronyms, and perhaps you might have come across in your past or also in your work. So we will address some of those things. And then we will talk about a single point of failure. What does it mean? What are the impacts? What are the things that you need to prepare? And then we will talk about some of the solutions. What are the right solution for the right expectation for the high availability? Because high availability means a lot of things very differently in your situation, in your customer situation, or your departmental situation. In fact, we're going to make it fun. We're going to open up for the best question of this session. So please feel free to ask a lot of questions. At the end of the session, we're going to select the best question of this series, and we'll give away 25 euro gift voucher. So please don't be shy, post your question, and you will get a chance to win a 25 euro gift card to that. So with that, let's get going. Borys, high availability. There's a lot of definition. A lot of people have a different mindset, a meaning of it. So can you share with us what is the high availability concept about?
Yeah, sure, Kevin. Yeah, what is high availability? Yeah, high availability is the quality of a system or component that assures a high level of operational performance for a given period. Availability is often expressed as a percentage indicating how much uptime is expected from a particular system or component in a given period of time, where a value of 100% would indicate that the system never fails. For instance, yeah, for example, that guarantees 99% of availability in a period of 1 year can have up to 3.65 days of downtime, 1%. High availability has 3 key principles. The first, eliminate single point of failure, adding redundancy, so that the failure of any part of the system does not lead to the collapse of the entire system. Second principle is reliable crossover. In a redundant system, the crossover point itself becomes a single point of failure. Fault-tolerant systems must provide a reliable crossover or automatic switchover mechanism to avoid failure. And the third is detection of failures. If the above 2 principles are proactively monitored, then a user may never see a system failure. Let us discuss about maybe downtime. We distinguish between two categories of downtime. Planned downtime. This means maintenance, installation of patches, installation of new versions of software, replacement of hardware, adjustment of network configuration. Yeah? The application is not available during this time, but maybe it's no problem for a business because the operation can be planned. Other situation is with unplanned downtime. In case of unplanned downtime, one of components has failed and the whole service is down. If you want to know exactly how available your application is, you need to have a good overview of all components in your infrastructure. Often, only a part of infrastructure is considered. For example, DBA take care of database availability. Network administrators are responsible for the networks. And only the view of the full landscape can give an answer. How much availability is guaranteed for the whole platform? Now let's look at how availability is calculated. HA can be described in different metrics. Availability is measured in percentage and refers to operation without interruptions limited to 1 year. Availability is measured in several nines. 4 nines of HA mean the downtime of 52.50 minutes per year. 5 nines mean the downtime of only 5.26 minutes per year. For each requirement, a suitable infrastructure must be provided, since very few interruptions are allowed. For example, if the availability requirement is set at 5 nines, you should set up the infrastructure so that the service, and this means the end application, cannot be down for more than 5 minutes a year. Are we talking only about unplanned downtime here, or should planned downtime be included here as well? This is the question of definition. Both options are common, but in very critical environments, both planned and unplanned downtime is often calculated with several nines. Kevin, you're on mute.
Yeah, sorry, always that kind of mistakes. No, thank you, Borys, for explaining that, because a lot of time people have a different perception. Obviously, based on the application, how critical it is to get the data, to get access to it, has a different definition. I think you mentioned those percentage. I think this make it a little bit more fun. We have a poll actually to ask about what is your definition about high availability. So it would be great for you to select some of these options. You know, what does it mean to you? Is it mean just one of them, like a single point of failure, or is it just a reliable crossover, or detect failure when it occurs, or maybe all of them? So it would be great to get some information from you, a little bit your perception of it. We give about another 5 seconds. Yeah, it would be great if you can provide us a little bit more input. Okay, and yeah, let's see the result. Wow, a lot of people have voted for all of them, and some of them voted eliminate single point of failure, which is really good information. Thanks, folks, for providing that information to us. Let's move to another topic. Borys, you know, during the discussion, a lot of people use those acronyms. So can you give us a little bit background about what is RPO, what is RTO, what is a GRO?
Sure. Yeah, exactly. Let us discuss this RPO, RTO, and GRO. Let's talk about RPO now. The availability of the environment is very important. Very important is also the data that is processed with application. The stateful application to which the database belongs generate any and process data in transactions. In addition to infrastructure, the data should also be managed securely. If something happens, the infrastructure components can be replaced by redundant components. However, the important question is how much data may be lost during the failure. One example, an office records many documents in paper form, which are once stored in the office building. A copy of the document is taken to the archive. Archive building is located 1 kilometer away from the office. If a fire breaks out in the office building, the documents stored in this building will burn. All unfinished documents, documents that have not yet been copied and transported to archive, will be lost. The copies that are already stored in the archive or on their way to the archive, these documents are saved. It's the same with data in IT. When you book a trip in an online travel agency, you must enter your data in the portal. Yeah? This is often data such as destination, transportation, hotel service, etc. All data is saved to the database, in the database. If the system does not have redundancy, the data will be lost if the system fails. And recovery point objective describes the requirements of how much data may be lost in the event of the failure. In other words, if a system fails, how much data loss can be tolerated. This is measured in time. Let's explain the RPO in an example. If the requirement for RPO is 2 hours, it means that my system, in worst case, may lose 2 hours of work or 2 hours of data produced in this time. These requirements usually come from the application, or often they are the business requirements. Now let's talk about the next topic, recovery time objective. In some scenarios, when the service fails, you need to repair the system very quickly or bring a standby system online. You may need to restore data from backup or other sources. However, it's often very important to restore operation without waiting until all data is fully restored. For example, we can imagine a web store where all revenue is generated from order placed through the web presence. If such system fails, it's essential to bring the web service back online as soon as possible. The orders and purchase transactions that are affected by failure and where the data may not be complete can be analyzed and updated later. But the web presence should resume work in a few seconds in case of failure. And this describes very well what recovery time objective means. How much time a system may be down, or in other words, how fast application should be back in operation after an outage. The system must be online as fast as possible. Business can't wait. RTO and RPO are very good bases to evaluate and analyze risks associated with system failure. The less failure and data loss is allowed, the higher are the costs to be provided to design high availability systems. Because HA landscapes tend to be complex, additional effort must be calculated into the operation. And companies also need very highly qualified employees who can master such complex platforms. Now we come to the next aspect, geography recovery objective. This is mostly associated with disaster recovery. If their data center or fire section or significant part of the infrastructure has failed, how much time does it take to get those all components up and running in a different location? Obviously, such outages present a significant challenge. The RTO and RPO must be clearly defined in such cases, from the technical but also from the financial and business point of view. The solutions that guarantee fast recovery and little to no data loss in geographically secured environments can become very expensive and complex.
That's great. So in fact, it's not just about technology, it's more about the business requirement, isn't it? Because when customers say, I need that, there must be some sort of a business requirement definition about the recovery point objective, and there's going to be time limit that they need to cover as well. They cannot lose, let's say, one day, then they can define, I can only lose 1 hour of data or recovering that 1 hour back. So I think, so what you're describing is very much on the business side of things, right, as well, not just the technology side of high availability requirement. Just out of interest, again, I want to remind the attendees, participant, please feel free to ask questions using the Q&A. As I said before, we do have a prize for the best question. And in fact, I've got one already sent to the Q&A question. So Borys, there's a question. People perceive that high availability versus fault tolerant. Isn't it fault tolerant high availability?
Fault tolerance is the part of consideration of high availability. I think we need to consider several aspects to achieve the high availability, and high availability is just the definition. Yeah, you need to check the SLAs and requirements of customer for each system.
Okay, great. So let's move on to the next one. I think there are some interesting things that you're going to share with us, which is, I think, related to the question been asked, the single point of failure. So let's spend some time about that, right? Because a lot of people ask about that. Can you walk us through what does that mean and how do we resolve that kind of a single point of failure?
Yes, exactly. As per the first principle of HA, eliminate single point of failure, we need to have a mechanism in the system which could help us to avoid the single point of failure. And the single point of failure in the database environment is a data. In Postgres, we can build the shadow database, call it a standby. And we have 3 ways or methods to replicate the data from the master to the standby database. The first method is wall file shipping. We could build a system in which standby can receive the wall files from the primary server in the form of archived wall files. Primary database is just archiving the wall files using command mentioned in the parameter archive command, and standby will be receiving the wall files using the restore command from archived location. The second method is called as streaming replication. We can build a system in which standby will stream the wall information, each transactions, from the primary to standby using libpq protocol. Instead, receive data from the archive location. And the third method is a logical replication. We could build a system in which standby is not physically clone of the master. In this case, some tables in the database can be replicated to the standby database. How does it work? Primary database use one of logical decoding plugin to decode the wall files and apply the generated SQL statements on the standby. There are advantages on logical replications. For example, you can avoid the human errors, or you can perform major version upgrade with minimal downtime approach.
Yeah, so in fact, of the physical, we hear very often about replication, hot standby, cold standby, warm standby. Can you explain a little bit about that phase, please?
Yeah. Hot standby is the term used to describe the ability to connect to the server and run read-only queries while the server is in archive, recovery, or standby mode. This is useful both for replication purposes and for restoring a backup to a desired state with great precision. The term hot standby also refers to the ability of the server to move from recovery through to normal operation while users continue running queries and keep their connection open. As I already said, we have different ways to replicate the data. Yeah, the physical replication, the first and old method is file-based log chipping.
Yeah.
Whole logs files are chipped from the master to the standby server to keep data in sync.
Yeah.
Master can directly copy the logs to standby server storage or can share storage with the standby servers. One log file can contain up to 16 megabytes of data. The whole files is chipped only after it's reached that threshold. This will cause a delay in the replication and also increase chance of losing data if the master crashes and logs are not archived. Sorry.
No, that's great explaining. Sorry, I interrupted you.
No problem. Yeah. The beta method is the streaming replication. By streaming replication, whole record chunks are streamed by the database server to keep data in sync. The standby server connects to the master to receive the whole chunks. The whole records are streamed as they are generated. The streaming of whole records need not wait for the whole file to be filled. This allows a standby server to stay more up to date than it is possible with file-based log chipping. By default, streaming replication is asynchronous, even though it also supports synchronous replication. And synchronous replication, is very good thing to protect your data. If the primary server crashes, then some transactions that were committed may not have been replicated to the standby server, causing data loss. The amount of data loss is proportional to the replication delay at the time of failure. Synchronous replication offers the ability to confirm that all changes made by transaction have been transferred to one synchronous standby server. This extends the standard level of durability offered by a transaction commit. This level of protection is referred to as too-safe replication in computer science theory. When requesting synchronous replication, each commit of a write transaction will wait until confirmation is received that the commit has been written to the transaction log on disk of both the primary and standby.
Yeah, that's great. We will have some example in a minute. In fact, we have one question from Jaffa posted on the Q&A. So he said, how can we achieve active-active clustering using the shared storage with Postgresql rather than replicating data from one server to another server for the redundant storage? Replication requires redundant storage, but active-active takes the advantage of shared storage with multiple servers. We're going to talk about active-active in a minute. Do you want to answer this, or you want to wait until later?
I can answer this question. I think the Postgres has nothing to share philosophy. It means Yeah, I can understand. The question is coming from the Oracle Real Application Cluster area. And yeah, in Postgres, we cannot use the share storage to access from more instances, yeah, actively, yeah, to write. We have other solutions, yeah, to achieve the same goals. What can you achieve with real application cluster, yeah? But we will discuss it a little bit later, yeah.
Okay, great. Another question came in about RPO, RTO. So Marian actually asked, human errors happens a lot, right? Some people say deleting record, delete from table where employee in Germany, boom, and suddenly happen error. So part of the RPO, RTO consideration, or are there any considered independently from that to avoid the human error?
Yeah, it's very good question. Thank you. Yes, we can use with physical streaming replication. We can configure a delay. The data will be transferred to the standby database, but not applied in the real time. Yeah, we can configure, for example, 2 hours delay, and we have the possibility of our standby will be delayed. Yeah, and we have the data before this human errors occurs. Yeah, that's one thing what we can do. Second thing is the logical replication. We can combine our physical replication, maybe one standby with delay, or we can replicate the data logically, and then we have the second method to protect against the human errors.
Yeah, that's great. Okay, so we have a couple of other things to cover as well. Reliable crossover detection. So can you talk about the crossover detection? If something goes wrong, how does that redundancy system work, and how do you detect it? What's going to be the action? What are the things that can take place? Can you walk us on that topic, Borys?
Yeah, sure. Yeah, if we look closely, the unit that decides which part of the system has failed plays a crucial role. Yeah, this can be compared to a general staff of the army which plans the battle. The situation should be monitored, and moreover, a quick and above all correct reaction to the event is required. Such staff is also needed in HA environments, which monitors the replication between master and standbys, checks whether server and databases are functional, and network communication remains up. The more information is available, the faster and more accurate a decision can be made to perform a recovery action. What actions are available? In database world, a failover must be performed when the primary database is no longer available. From time to time, it may happen that a master system fails. Automatic failover is performed and the old master machine is restarted. In this case, it can happen that the old master reports as master, and we get 2 databases claiming that the 2 are masters. This is so-called split brain situation that can also occur. In order to avoid the split brain situations, the software that takes care of such switching should also be able to counteract these situations. Such central systems which are responsible for failover have a crucial importance and should also be designed redundantly. When choosing HA system, you should make sure that they meet the HA requirements. Don't forget that even central systems that monitor database must also be monitored and protected against failure.
So I think you talked about this automatic failover, avoid the split brain scenario, reconfiguration. So there is a solution you're going to do and demo you're going to walk us through, right? So Can you explain about your demo and share it? What you're going to present?
Yeah.
Should I stop sharing?
Okay. I will now. Exactly. You can stop, and I will share my screen. Just 1 minute or 1 second. Okay. Can you see my screen?
Yep, we can see.
It's good. Okay. EDB provides a very good tool for high availability to create, to monitor the high availability environments with master and standbys. Tool is called Failover Manager. Is agent-based monitoring and protect the system from failure. Yeah, if the master fails, the EFM can make failover. EFM can also handle the virtual IP address and reconfigure this virtual IP address for accessing from customer request to the new master standby, can interact against split brain situations. And let me show you EFM in action. Yeah, I have my system with one master, with one standby. It's very simple setup, and you can see that my master, primary, and standby are online, and the databases are in sync. Yeah, I have the same log sequence number. I have the third terminal. This is the client terminal, and I will connect me to both databases, to master and to standby, but with attribute read-write. It means I am connecting to master. I have one table emp. I can select the table, and I can really check who I am. Please see the IP address. This is IP address from my master server. Now let me shut down the master or primary database, and let us see what happens. I'm going to Enterprise DB, and I will just stop my database. Let's check the monitoring. The EFM manager detects the failure and start my standby database as the primary. Yeah, everything is okay. The failover is executed from a failover manager, and on my client, I will try to select my IP address. The first execution will reconnect me to the new master, and we can see now that the IP address is changed. I am on the master, but master is the new master. And I can now also select my emp table. But the situation is not good. Yeah, we have now one master. Okay, it's good for operation, but we don't have any redundancy. Yeah, and in this case, we can do something. Yeah, I will try to start my old master, and you will see that it cannot be executed. Yeah, could not start the server. EFM contracts against the split brain situation, because we have already one master, and now we need to make our old master at the new standby. We have for this we can use PG Rewind script. Yeah? PG Rewind is open source tool, and I can, with help of this script, just reconfigure my old master at the new standby. I automated all steps that are needed, and we can see now we have our old master as standby, and everything is okay. The last step of the demo that I will show you is switchover. Yeah, in some situations, in minimal downtime upgrades methods, we need switch over to make standby first patch methods, and we can very good make the switchover with EFM manager and change the roles. Yeah, and you can see that in 2, 3, 5 seconds the roles are changed, and I have now my old primary as primary and my old standby as standby, and everything is in sync. Yeah, thanks.
That's great. So you actually demonstrated the point about the automatic failover, but at the same time, you also show that the master become a standby, and once it's standby, you can use the switch over and switch it back and reverse from the standby back to a master node.
Exactly.
And this is all automated with the tooling.
This is automated with the tooling, and we can use it by patching processes. Yeah,
that's great. So that's great demo. So another part about the logical replication. Can you spare a little bit more time? You talked about physical replication, but what about the logical replication?
Yeah, sure, I can do it, and yeah.
I think you have an example here, right, with a use case.
Exactly. The logical replication is the good choice if you need for example, yeah, if you will protect against the human errors, yeah, because we replicated the data logically and not exactly the copy of the master database with all human errors, but the subset of the database. Yeah, and it can be very good method to protect against the human error, the logical replication. Yeah?
Right.
Second thing, you can with logical replication replicate data between different operating systems. Yeah, for example, between Windows and Linux. Yeah, it's good one if you have to replicate data between different systems. You can also use the logical replication. We can have multi-master systems. Yeah, in our streaming replication mode, we have only one node to write workloads. Yeah, and we cannot scale the workloads. Yeah, in logical replication allows us to have several masters to write on different locations. Yeah, we need, of course, we need, we can receive the conflicts. Yeah, we need to interact with this. Yeah.
So you gave an example here about the different logical replication with bidirection. So I think you're going to share us with this logical replication from different nodes, different location, and I think this is the always on architecture you're going to share with us, right? With two data center with 4 nodes. So do you want to share with us the demo, how those things works?
Yeah, yes. I will share with you.
Yep.
Exactly. I will share with you the demo for BDR. Okay, yeah, the BDR is the next generation of the logical replication. Yeah, with logical replication, we can have multi-master setup, but we need a bidirectional replication. Yeah, bidirectional replication means I can replicate the same data across the nodes, and I have some conflicts. Yeah, and BDR allows you to interact with different type of conflicts. And we have different utilities to make it possible that the conflicts will be resolved. let me describe in this demo how BDR is working. Yeah, I have 3 nodes, BDR, 3 masters, and I have my table. I have my table match to save some football data. Yeah, and you can see I have different columns, and ID is my my primary key column. And at first, I would like to demonstrate how works the implicit commit. I will just insert the data for one game, football game, on the first node, and we can see what the data it's written on the node 1, is written on the node 2, and also is written on the node 3. Yeah, the next one is I will start the transaction with begin. Yeah, I can just on the node 2, because we have the multi-master setup. Okay, now exactly. I started my transaction with exactly with begin. You can see exactly begin, and then I inserted one row to my table. We can see that I am not ended my statement, my transaction with commit or rollback, and I can see on the node 2. Okay, now 3 rows, and on the other tables we can see, yeah, this one exactly. This one we cannot see this row because the transaction is not ended at the moment. I will now say rollback or commit, and then the transaction will be rollbacked on this node or committed on all nodes. With commit, I can see all 3 rows.
So you mean that when you commit, it will synchronize all the nodes together,
Exactly.
so that they will get the data?
Exactly, exactly. And yeah, we can also make, with BDR, we can also make the details. We can update the table, we can delete, and these actions will be also replicated. Yeah, and this is really a feature of BDR that I can now, for example, demonstrate you update my table and change the data. Yeah, no data, the time. If my ID is 1002, yeah, I updated to other date, and we can see that the date is changed, and I can is changed, also changes replicated to other nodes.
So with that, Borys, just wondering, we get some question as well. When you do the changes, does it change the data and you replicate the data to the others, or you replicate the log file, or you replicate a DML to different nodes? How do you replicate from one server to another servers?
The data is the logical replication is using the wall file informations.
I see.
But also it will be saved more information for each transaction. It will be saved the DDLs, and it will decode the DDLs in logical layer, logical buffer. Yeah, and yeah, it will be replicated from logical sender to logical receiver. Yeah, it will be transformed. It's not the physical replication; it's real logical replication.
That's great. So thank you for the demo for that, Borys. So that's great to see that the differences between physical and logical replication. The logical replication. So we have a poll. So what does it mean in terms of service level agreement for all our audience? Some people say, is it 99%, 99.9, or 4 nines, 99.99, or 5 nines, 99.999. So I just want to see, what are the typical requirements for you to have a high available system in your premises, in your project, in your configuration. We give about 10 seconds, and we roll back. Meanwhile, we got a lot of questions. Please feel free to come in with those questions, right? So as I mentioned at the beginning, we will give away a €25 gift card to the best question. Great, so we got a result. Oh, wow, it's going to be split. So some 22% 99, 70% 99, 3 nines, 30% 4 nines, and 30%. Wow, it's very different. I didn't expect that, but I think it's a good variation from different part of things. Great. So let's talk about, right? You walked through with us different types of solutions, master standby, physical replication, master, logical replication, all that. What is the right choice for the right solution? Can you spend a little bit more time on that, please?
Yes, of course. Yeah, the logical replication, have some advantages. For example, we can, with solutions based on the logical replication, have less downtime by upgrades. For example, very important, we can with BDR make the major Postgres upgrades with no downtime, with 0 downtime. Yeah, for example, as I already said, we can scale the right workloads in logical replication because we have really multi-master setup with the logical replication. We can replicate data between different Postgres versions and different operating systems. But the logical replication is very complex to set up and to maintain it. And if you need only 4 nines of HA, maybe the physical replication is very, very good choice for you. If you need more HA, 5 and more nines, you need to consider maybe logical replication.
Okay, so that's great. So we will share the slide deck with the audience. So you will get the slide and those things that Borys already walked through, or verbally, we will put it on the slide deck. You can read through them. So we got lots of questions. So let's start the Q&A, Borys. There's a question from Tesfai, how Redundance handles SPOFS. How does that Redundance handle that?
I think this question is, okay, SPOFS.
You know what that is?
Single point of
failure. I'm getting old. I'm getting a lot of acronyms. Yeah, so thank you for that. Yeah.
Yes, you need. If I right understanding the question, we need each component of our systems to handle a single point of failure. Yeah, you need to determine. For example, we have web shop. Web shop is configured. You have web servers, you have application servers, you have databases backend, you have storage, you have network, you have other facilities, and you need really to define the goals to SLAs and to define how redundant must be your system and you need to handle each component. and and then you will not have any single point of failures. And you need to monitor the system, and you need to monitor the monitor system.
You have a lot of systems. So I think the single point of failure is not just software, it's hardware as well, right? Storage, network, a load balancer, you need to duplicate all that. So I think it's a lot of things that to think about in the single point of failure. We have another one. Which replication model is the best for production? The wall shipping or the logical streaming? You know, what is the best meaning of less human interaction for that?
I think, I think it's the good question. A streaming replication is better as the wall shipping. Logical streaming, maybe, if your production, if you need you can counteract against human errors. You can better maybe with the logical replication, or you can also have the streaming replication standby with delay. You need to decide what is important for you. The normally, if you have requirement with 4 nines, the streaming replication is a good solution for you.
Great. Is there any device that like Oracle FarSync to replicate to many standby databases?
Yes, in Postgres, the replication, you can replicate the data from the master to the several standby databases. And you can do it also synchronous and asynchronous.
Okay, great. Shall we also ask what are the recommendations or a requirement for some of the African countries which faces telecommunication issues and want to have high availability with Postgres? I think you demonstrate failover, which is the physical replication. You can have a standby, so you're not relying on the network or telecommunication, I suppose.
I think this is the question. The need very stable network, for streaming replication. And maybe in some African countries, it's the infrastructure not the good. I don't know. And by logical replication, you can replicate data really asynchronous, and the network stability is it's not the requirement. I think maybe you can use for unstable networks the logical replication.
Okay, great. Mark also asked another question. What are the advantage of EFM compared to PAF or Patroni?
I think
what are the differences?
I think the advantages of EFM are what EFM is. I would not go to the technical deep dive comparison, but EDB is very common, very famous internet company in Postgres area, and we have very strong roadmap for EFM, for example. For example, Patroni is developed by 2 developers from Zalando, and you cannot be sure if the new version of Postgres is released, the Patroni will working, but EFM will be always working with each Postgres version, because EDB is a part of the community, and we developed it very closely with community. It's community, and the features, EFM has all features to achieve the high availability.
Okay, so we have another question regarding GIS. So a question about the Postgres GIS and logical replication. Is it possible to use logical replication from Postgres 10 plus or Postgres 2.4 to Postgres 14 and Postgres GIS 3.2? So can we use the logical replication for the Postgres 14 and Postgres 3.2?
I think for logical replication, you need to create the same tables on both masters, yeah? And then you can, if you can create the same tables on one master and two master, you can start to replicate the data, yeah? And if you are able to create the tables with similar data types, with exactly the same data types, yeah, you can replicate the data. Yeah, Postgres 2.4, I don't know, the logical replication, native logical replication in Postgres was introduced in Postgres 10, yeah?
Mm-hmm. Yeah, okay. We have another one. Is there any data loss between the PG rewind and PG rewind will roll forward only for the primary and both primary and the standby?
PG rewind will roll forward the data on the old primary, would be changed to standby. PG rewind can be used if you have in replication slots, yeah, all informations that are saved from the time failure time to until the time to restore. If you don't have any all informations in the replication slots, yeah, you need to create your standby with PG based backup or other method.
Okay, so we have a lot of questions, so I'm going to pick a couple of them. So there is one from Abraham. How does the multi-master replication handle a master been down for some time? I think this is the weakness, I think. If the multi-master replication handle the master been down for some time.
Yeah, you can, for example, if you are using, yeah, you need to use your environments with multi-master, maybe with PG bouncer and HA proxy or some mechanisms that you can, yeah, the data, if the master is down, is planned downtime, you can redirect the new request to the other masters. In this time, you can, if the master is down, it will be written on the other master, for example, in replication slots also, and then if the first master is online, you can replicate the data, yeah, from the old master to the not old, from the online master to the second master, yeah. We have also the tools, yeah, like live compare. What can you help to check the differences into databases and calculate how much time is needed to synchronize the databases?
Great. I think I appreciate all the attendees, participants posting all the questions. Unfortunately, we are top of the hour. We will definitely look at some of those questions that are still open, and we'll respond to those as well. And yeah, again, if you have questions, you can also use our alias email address, like Ask the Expert, simple, at enterprisedb.com. Our expert will look at those questions and reply back to you. And there is a poll. So would you like us to follow up the call with the EDB expert to discuss some of the topic further? So please make a choice. You can say yes, no, or maybe. Then you know, we can also get in touch with you if you have any questions. Okay, fantastic. So, and the winner from the panel and from Borys, and we have a couple of those monitoring the question. And the winner is, let me just read. The team actually said Marian Scott Morgan.
Exactly.
Yeah. And she asked the question about the user errors instead of planned downtime. We think that the panel voted for that. So congratulations to Marina, and we will send you the gift card for €25, and you can use it however you want. So again, we will repeat this every month. So by all means, that please visit us. The next one is going to be the 9th of March. We will have the database in the cloud, and one of our experts will present and talk us through what are the cloud in the database, what are the options, what are the best practices. So with that, I don't know, Borys, have you got any last wording you want to share with the team?
Not from my side. Yeah, I'm looking forward to other expert seminars, and yeah, if you have some questions, feel free to contact me or us, our team. Yeah, we are very happy about. Fantastic.
So I very much appreciate for all the attendees staying with us. We got a very good audience asking loads of questions. So I look forward to the next session. So I wish you all have a great day. Thank you all.
Thank you.